Good afternoon. Glad that you guys are here. I think you'll appreciate this session, though. It has some of my favorite demos, and I really like to prove some of the points that I'm going to show as far as VLDB availability, because when some of you are creating larger and larger databases, or let me take a step back, actually. Some of you struggle to create larger and larger databases because in SQL 2000 today, if something goes wrong with that larger database, it may take that entire database offline. In fact, it usually does. In SQL 2000, if there's even just one page that's damaged, that entire database is likely to be unavailable. Well, in SQL 2005, things are significantly different with respect to larger and larger databases. So what that means is that since your managers, since your customers are very likely to want more and more data available, a larger historical amount of data available, you can have that in one database and still keep that database available even if part of that database becomes unavailable and damaged. So what we're going to focus on is how to keep a database available using SQL 2005 features. I can kind of give you some insight into the comparable 2000 features where there are some, but most features here are not in SQL 2000. They're solely in SQL 2005. So my name is Kimberly Tripp. I've been working with SQL Server since 1990. For the last 10 years, I've been doing training, consulting, speaking at conferences like this, and working with customers mostly on performance tuning and availability. And a lot of people think availability just means clustering, but it really is a much larger and wider, more encompassing set of tasks. It's performance tuning, because if your database is available and it's not performing adequately, what's the point? Right? If a user can't get done when they need to get something done, then they're going to end up going to another site, to another competitor, and they're not going to necessarily come to you. So availability to me means looking at making sure that your systems are optimal, making sure that you've looked at all of the different aspects to availability, not just keeping the system highly available, but look at what your barriers to availability are. And some of the biggest barriers to availability, I hate to say it, are not technology, right? It's the accidental table deletion. It's the, I mentioned this, that somebody came up to me once and said, how do I get a sysadmin to not be able to drop tables, right? How do you prevent a system administrator from dropping tables? And you jokingly want to respond, get a new systems administrator. But it really is different than that. It's the accidental, I'm connecting to a development server, I'm working, I'm getting a phone call, I have to go quickly check something in production, I hit that machine for a few minutes, and then I kind of go back into my development screen and I open up a new window and it connects to the last server that I was connected to, which happens to be a production box. I go and I quickly drop that table that I'm working with in development because I'm not thinking, and bam, I've just dropped a table in production. I mean, the good news is that if you're the one who damages the data, you know the extent of the damage. And sadly, that is actually very good news, because now you know what the extent of the damage is. When you have damage that you start finding out about, you start wondering, when did that damage occur? What's the extent of that damage? And what are some of the ways that you might end up investigating that problem as well as recovering from that problem? And some of these new features in SQL 2005 will significantly reduce the amount of time that it takes for you to have something that you can use to evaluate, investigate, and recover from. So what we're going to look at here is what happens when resources become damaged and unavailable. We'll look at how you can strategically create a database in such a way that it will be more likely to stay available through, I don't want to use the term partition tables, because you don't have to use the new SQL 2005 feature to benefit from the availability features I'm going to talk about. But you have to do some form of strategic, functional partitioning of your database. You have to place objects more strategically in 2005 to leverage some of these features, and I'll show you how to do that. So file groups and partitioning, and possibly partition views like you use today in 2000, or partition tables, which some of you may use in 2005. Then we start wondering, okay, now that we've taken all this time to partition our database and strategically place objects in certain files and file groups, what happens when the physical devices on which those tables reside become damaged? And the answer is, it depends. But you can, in a lot of cases, keep your databases more available if you strategize for this. Like, let's take some of those larger tables for a second. You've got a table that has, oh, and let me take a step back for this on size. I had somebody that sent me an email recently. I was at your TechEd partitioning session last year, so 2004, and they said one of their colleagues was at the session last year. And he came back really inspired and started partitioning like all of our tables. And in one of our MSDE databases, we have a 16 partitioned view. And I kind of went, did you hear what edition of SQL Server they were using? In one of our MSDE edition databases, there is a physical limitation on database size there. Does anyone know what it is? Yeah, it's 2 gig in 2000, and now SQL Express is 4 gig. I would not even in any way, shape, or form start to consider some of these more complex strategies for databases that are under 10 gig, okay? Single-digit gigabytes are not really the types of databases you're going to want to create partition scenarios in. But certainly for those of you that have larger and larger databases or want to have larger and larger databases where you're keeping more of that historical information online, that's where, when you start to achieve VLDB, larger and larger databases, you want to consider a lot of these features. To me, I don't have a size that I want to directly associate with that. Some people say the database has to be more than a terabyte before you even start thinking about this stuff. And to me, that's way too late. I mean, I want to design this for a database that is maybe even in the 60, 70 gig range, because I think that I might keep data online longer so that it does scale really well up in terms of size to a few hundred gigabytes up to terabytes in size. Now, database snapshots, something I'm going to talk about at the end, doesn't matter what size the database is. You may want to take advantage of database snapshots. But partitioning and a lot of the work that goes into partition tables, that's usually for the VLDB scenario. So, file groups, partition tables, partition views, those are some strategies that can lead to better availability in SQL 2005. And then, what if it does become damaged? What happens today in 2000, right? We lose access to the database is offline until we complete the entire process of recovery. That's not true in SQL 2005 if your databases are designed appropriately. And then I'll round out with database snapshots and talk about what those are and where those are beneficial. So this is really the concept that is critical to understand in terms of VLDB. Even if your database is really large, even if you have a database that's 1 terabyte, you could very easily take all of the different RAID arrays, drive D, drive E, drive F, drive G, whatever they are on your SAN, and you can end up creating files on each one of those logical drives. Then you could end up creating one file group that basically covers all of those different files. That is one strategy that, to be honest, is very simple. It's a very simple to administer strategy that can give you some great performance. It's kind of the concept that you are leveraging the full set of all those disks easily by placing that object over the disk. You're using all the disks all the time. Great. But if you have one table that, let's say, is 874 million rows, and it goes over many disks, and one of those disks fail, that whole table is going to be unavailable. If you can take a table and break it down more logically into smaller chunks, then you could manage those smaller chunks and possibly have a lot better performance in terms of some of your management operations, not just availability. Think about that. If you have a table that's 847 million rows, or 874, it doesn't matter. You have a very large table. If you have fragmentation in that table, and you have to rebuild that table in 2000, that takes that entire table offline. But whenever I see a table that's measured in hundreds of millions of rows, that is not 100 or hundreds of millions of rows from yesterday, right? It's this month, right, July 2005, but it's also June 2005 and May 2005. It could be sales for our company, right, from all the way back to 2000. I could make a lot of arguments that if 2000's data were to become unavailable, it really shouldn't in any way, shape, or form negatively impact my system. So if I can strategically place certain data in one location, other data in another location, other data in another location, I can keep that database more available, and I can also manage it at those different, smaller, more granular chunks, because the data from June and beyond or below is not being modified, but July and above right now is. So that data needs to be managed in terms of fragmentation, whereas the more read-only data doesn't. So it is very important to realize that when you have different access patterns of larger tables, breaking those larger tables down can give you some great benefits. So what does this depend on? It depends on access patterns. It depends on how you're accessing that data and the types of activity that's occurring against that data. So those are the first things you have to think about. And then when I start pulling this into kind of the design, I also think about what happens when something goes wrong, right? If I'm looking at that table and I think about a hardware failure, if I say, what happens when a page fails? The scenario of disaster is different in 2000 versus 2005. So we're going to look at both of those just briefly. So what if there's a hardware failure, and what if there's a human error? Right? What if there's a table that's dropped, or what if there is an accidental data deletion or data modification? Now, we can talk for a while about preventative techniques for sure, but there is no way that you are going to prevent every disaster from happening, because there's going to be something that you don't foresee that may be the one that gets you, and then you'll have to put something else in place after that. This isn't something like you set up for high availability, you create it, and you walk away, and now it's going to run 24/7 for the next 10 years. Right? You need to constantly reassess what's going on that server. But these are some great strategies that will keep your database more available. So let's start with 2000. If you have any damage whatsoever in a database in 2000, that entire database is essentially offline and marked suspect. Right? How many of you have a history with SQL Server that goes below 6.0 even? 4.2? Any of you? I love to ask this question just for a second. If you had a damaged database in 4.2 and it came back and said it was suspect, does anyone remember there was a dbcc command that was called dbcc db repair? You got really excited about it because you'd go to the books online and you say, oh, my database is suspect, dbcc db repair. It had one option: drop database. Problem solved, right? I no longer have the problem. Obviously, that's not the strategy we want to take. What is much more likely is that we want to keep that database online and available. We don't even want it to be offline. So if we just have a piece of that database that's damaged, why drop it and start from a backup? Maybe we can continue to access that which is available. But in 2000, that's not the case. Going way back in SQL Server, that's not the case. So this is a very new concept in SQL 2005 to have partial database availability. To have a database that is partially damaged, yet keep that database online and available. So in SQL 2000, if you have an isolated hardware failure, that database is offline. In SQL 2000, if you have some type of human error, right? First of all, you have to try to figure out when that error occurred. You have to then go to your backups, very likely, recover from a backup, and roll forward using logs. And what a lot of people would say is, well, what if that damage occurred 6 hours ago? Do I want to roll the entire database back to what it looked like 6 hours ago? Well, if you want a database that has absolute data integrity, that is generally the recommendation if you look solely at the features provided by SQL Server 2000, to go back to an image of the data as it looked 6 hours ago. Okay? Well, there are third-party products that can help you figure out what happened in the log, who ran and executed what. That can be very helpful. Lumigent Log Explorer, BMC Software SQL Backtrack. So there are some products out there that can help you read what's in the log and what happened. But what a lot of us do, very simply, is we take our backups and we restore them to an alternate location. leaving the currently damaged production database intact. Maybe we take it offline so that no one can access it temporarily. We go to an alternate location, we restore, and we start kind of inching forward in that database to find the point in time where we had good data and that good data was no longer good any longer because somebody did something to damage it. That's incredibly time-consuming because restoring, especially a VLDB from backup, takes a tremendous amount of time. So we have some features that will help this in 2005. So in 2005, the first feature that you really don't have to do much for except a little bit of strategic placement for your objects is partial database availability that happens automatically when you have some type of isolated failure in terms of hardware. If there is hardware that's damaged and certain parts of the database are available, the rest of the database that's not damaged will stay available. And I'll show you the criteria that must be met for this to be true. Now, for human error, if there is just a part of your database which is damaged, remember how I said you may want to take the database offline? And you still may want to do that. You have part of the database damaged, depending on what part is damaged, you may want to take that database offline. Well, in some cases, if it's 2000s data in terms of sales, you may want to leave the rest of the database online. So you can take just that part of the database that's damaged offline. And you can use now something called a database snapshot to end up looking at maybe the earlier version of that data and bring that data in to your production environment. So especially when you're talking about human error, having a snapshot can be incredibly useful. So we're going to start looking at how you manage each of these environments. So now, how do we make this possible? You have to do some type of fine-grained design to your database. It doesn't necessarily mean the partition table feature, but it does mean that you partition your database in some way by strategically placing objects in certain files or file groups. Now, again, I want to stress you don't need to use partition views or partition tables. However, partition views and partition tables significantly benefit from this feature. So they're really a great combination together. But the availability features do not require partitioning. However, that is what I'm going to do to show you this. So your strategies, you really have two. The one that's probably the more common that I see, because I tend to see VLDB that are based on large amounts of usually ever-increasing sales type of information. That's very common, that you want to allow your customers in banking applications to go back and look at transaction history, not just from July of 2005, but for at least the last 6 months, or maybe the last year, or maybe the last 2 years. And when you're talking about a bank that has 28 million customers, 9 million transactions a day, 200 gig of growth per month, and a currently 20 terabyte database, you start thinking, if I want to leave even more of that data online and available, then I need to start thinking about how to not impact the database if part of that database becomes unavailable. And this is what we call the sliding window scenario, where you want to keep a certain amount of data, and you may even want to change what that amount of data is each month. Some people just continue to add data into kind of the analysis type of database and get rid of old data, right? So you might bring in new data, get rid of old. Bring in new data, get rid of old. Some people just continue to bring in new data, and their database keeps getting larger and larger and larger. You don't have to be getting rid of the older data if you don't want to. And in fact, in 2005, you can keep more of that data around longer because it doesn't as negatively impact your database to have larger and larger databases. So date and time-based placement is probably one of the most common. Okay? And this will very likely leverage partition views or partition tables. Now this is the other strategy that you can use. If you have objects that are related, but maybe not entirely necessary to all be available for all sites. Like we take something that is kind of strategically placed in terms of location. We might have different states with whom we do business. We might put all of the California information in one particular file and file group. We might put all of the data for Washington in a different file and file group. And if California's data becomes damaged, then we can keep that database online and available, continuing to allow Washington to make their modifications, continuing to allow Oregon to make their modifications. Okay? But if you start to think about the file group that contains all of the product information and pricing, that might be a file group that if that becomes damaged, you want the entire database to be offline. So, really important to be thinking about this in terms of design, because you might want to check for certain types of errors. And if you have an error in parts, you may want to take the database offline. But if you have an error in any of the other file groups, you may want to just allow the default behavior to continue, which is you'll get the errors and the rest of the database will stay online. Washington can keep processing, Oregon can keep processing. So now, how do you get this to work, right? How do you implement this? It's actually very simple. Every database has two files no matter what. We have the data portion and the log portion, right? And primarily when you create that database, the first file is a very critical file for data because it contains system information. It's the primary file. That file is actually critical in 2005, more critical than it's been in almost any version of SQL Server prior to 2005. So what's important is that you may want to, if you want to use this strategy, put this first data file, make it small, isolate it, and put it on its own file and file group, and don't put any user-defined objects in it. And then strategically place your log on its own isolated disks, because it is also critical. If either the primary, the first MDF, or the log ever become damaged, this database will be offline. It's the secondary, non-primary data files that do not cause the database to be taken offline. Those are where you're going to place your own data. So, data file and log file, that's usually how we start. But the way that you're going to get this feature, this strategy to work for you is to use secondary, non-primary data files for your data. And usually more than one. In fact, you may have 10 or 12 or 20 files depending on the amount of partitions you want to create. You want to do this based on regions, you can do that. You want to do this based on months, you can do that. And you don't even have to do this on consistently sized sets. You could put all of the data for 2000 through the end of 2001 in one location. And then you could put all of 2002 in one location. So we have 2 years, then we have 1 year, and for 2003, because maybe our sales were increasing, fingers crossed, right? And in 2003, we have 2 files. And for 2004, we do this by quarter. And for 2005, great growth, we're doing this by month, right? And you can break down your objects into any sizing that you want. But it's the physical disks on which they rely that is going to have the biggest impact to you. I mean, yeah, you can have damaged files, but it's much more likely that you'll have damaged disks rather than damaged files. And I know most of you are using RAID. In fact, I would expect all of you in here for VLDB are using different types of RAID arrays, but here's the cool thing. Most of you are probably using something like RAID 10 or RAID 0+1, because those offer great performance and really solid redundancy. I know some of you are using RAID 5. That's kind of what I call poor man's fault tolerance, because it is very vulnerable and it doesn't perform as well. I could spend an hour on my diatribes on different RAID arrays. I'm not going to do that. But my point is, if you start looking at the cost of all those disks in a RAID 10 RAID array, right, and then you say, well, wait a minute, 2000's data isn't as critical. I'm going to put 2000's data on RAID 0. You can do that. You don't have to make everything fully redundant any longer, which is going to allow you to be more cost effective for the larger databases and allow you to keep more of this information online, because with these secondary data files, you can say, okay, I'm going to create a data file here on a RAID 0 RAID array, and I'm going to then strategically place my 2000 data on it. So you can end up being more cost effective and still keep those databases fairly highly available. Now, I would still try to use RAID if I were you, but again, if you're trying to be more cost effective, you could go with RAID 0 and it won't negatively impact the database. So, how do you do this? There's 2 ways. You can take an object and you can say that you want this object on a file group. We can do that today. Okay, there's nothing new in that scenario. You can take a table and you can say, I want this table to be on this file group. And that file group may consist of only one file. That file group could consist of more than one, but in many cases it might have just one. So you might have a disk a logical disk, regardless of how many physical disks it makes up, right? So you have a logical disk, drive F. Then you say, I want to create one file there. Then you basically put a logical name over it called a file group. You place your object there, and that file will store that particular object. So we have that capability today. What we have in 2005 that's new is the ability to take one table and put one table across many file groups. And that's placing an object on a scheme. A scheme is a totally new concept, and I don't want to get it confused with schema, but it's called a partition scheme. It's a scheme for partitioning your data. But you can't just have a scheme, you have to have a function. So what we need to do is understand how schemes work. But just at this point, the ability to put an object on a scheme allows you to put an object on more than one file group. So this is actually a 2000 diagram, but I like it because I want to differentiate the two types of environments that you're working in. You can have one table on one file group that consists of, let's say, 4 files. So if I do that, if I create 4 files, and then I put one file group over them, and then I put data in it, let's say one table of a year's worth of data, then I will end up having all of January here, February here, March here. In other words, I don't necessarily know where each of those months' worth of data is going. It is being proportionally placed across the files in that file group. If I then have a lot of fragmentation from the current information that's coming in, I have to rebuild this entire table. And that can be expensive, especially in terms of availability if I have to do this offline. Now, if I were to more strategically create a table that goes across either a partition scheme in 2005 or, since this is 2000, I obviously did something in 2000. In 2000, what I did is I created a file group and another file group. This file group is on one file. This file group is on one file. This is on one file. This is on one file. So 4 files, but each one is in a file group. And then I took one object and placed it over those 4 file groups. So now I had very functionally based partitioning. Only January's data went here. Only February's data went here. Only March's data went here. And since April was in the midst, let's say in this diagram, it's still being populated and loaded. But there's something that's very interesting to note about this, is it's going to be harder to strategize for this because each month may have different or varying amounts of data. And you do want to size these appropriately. You want to think about the performance aspects of this as well. But the beauty in this scenario is that now that you've broken this data down into 4 more manageable chunks and you have separate objects or you have the partition table scenario in 2005, you can now manage these partitions individually. If January's data is not changing and I need to do a rebuild of that which is changing, then I don't have to touch this, I don't have to touch this, I don't have to touch, I only have to rebuild the current and active partition. And the numbers, just in this, I did a whole bunch of performance metrics off this scenario here that you just see the screenshot of. To rebuild the index in the first scenario, offline in 2000, took just over 9 minutes. And to rebuild only the piece of the index that was fragmented in the second scenario, it only took 44 seconds. So you're looking at a speed gain and an availability gain. Your table, and it's really only part of your table, is offline only for 44 seconds as opposed to the whole table being offline for 9 minutes. So lots of big differences. So how do we implement this in 2005? The differences here, it's way easier to implement the first scenario than the second. I'll give you that. Okay, but the second has a lot more flexibility in how it's managed. So I would highly recommend the second, even though it is more work to administer. If, in that second scenario, a file within a file group, well, in the first scenario, let's start with that. In the first scenario, if a file within the file group becomes damaged, the whole file group is offline. But in the second scenario, I had separate file groups. So if this file group, give me my mouse, here it is, if this file becomes damaged, only this file group is offline in 2005. Over here, since this is all one object, if this becomes damaged, it doesn't make sense, does it? I mean, if you think about it, I can't access this table without this cross-section of each month's data It doesn't make sense. But down here, you could argue, if it's just January that's damaged, why not let people continue to use February, March, and April? So this one has a lot more features associated with it, even though strategically it's more work. So let's talk about how we implement this. I am going to demo this using the SQL 2005 partition table and index strategy. I wrote a white paper that you can access from my homepage as well as on MSDN on how to do partitioning and all of the nitty-gritty details of it. And there are some really good secondary white papers that have come in the last few months as well. And there are links at the end of this session on all of those different resources. So if you want to get every little line of code and every little line of syntax, that would be a good place to go. And there's a whole bunch of scripts associated with all of those white papers as well. But the scenario I'm going to demo is called range-based partitioning. And range-based partitioning corresponds to my sales scenario, where I want to have ranges of data that are partitioned strategically on certain locations. Now, the way that you define this is through something called boundary cases. You essentially say, I want this set of data up to a certain boundary to go here. And I want the next set of data up to the next boundary to go here. And I have the next set of data. And the boundaries do not have to be every month, right? They could be very, very different. Like I mentioned, 2000 to the end of 2001 in one location. But what you do first is you define these boundary cases with something called a function. And that function, the nice thing about having an independent object to define your boundary cases is that you can end up reusing it if you have multiple objects that you want to partition with the same type of partitioning scheme. Imagine having an orders table that has the headers for sales, and then having a line items table or order details table that you also want to partition by month. Instead of having to do some of your complex partitioning for each table, especially if you want them to match, you're going to create an independent function. The function just defines the boundaries, though. How do you define the physical location? Well, that's where you create something called a scheme. So a function defines the boundaries, and the partition scheme is what's going to map those boundaries to physical locations within that database. So, interesting when you do this, though. You don't actually have to hard code in your date values, which is kind of interesting. You can write functions that will calculate a date for you at the time the partition function is created, so that if you want to automate the rolling range scenario, where each month, let's say you want to bring in a new month and get rid of an old month, bring in a new month, get rid of, you can calculate what is the month based on the current date and time, so that you can programmatically automate this process as well. So it's kind of nice the way that this has been implemented. You don't have to have hard-coded values for each of these boundary cases. You can also create, I don't know how many of you will do this, this isn't as likely, but you can create list-based partitioning. If you want to create regionally based sets, you can do this with partition tables by creating lists. And in the white paper, if you're interested, I do have a regionally based case study, so you can go through some scripts on how to implement that. But the one I'm going to do is going to be range. So we're going to need files and file groups. We're going to need a partition function with our logical boundaries. We're going to then need a partition scheme with our physical boundaries. So it's going to map each one of those logical boundaries to a physical location. And then we create our table on the scheme. So these are the steps. And this is what's in the script. I have two versions of this script, and I'll explain why in just a moment. You'll probably be able to implement one of them, maybe not the other. But step one is to create the file groups, then create the files in the file groups, create the partition function, create the partition scheme, create the table, and then load the data. So what I've done, like I said, is I've created two scripts to do this. Now, the one that I'm going to demo, and this isn't really my recommendation in production, is a database that I have partitioned across a USB hub with 4 USB keys. Now, this is not the most performant of databases, but what I've done is this is drive E, this is drive F, this is drive G, and this is drive H. And I have created a separate file and file group for each one of these drives, if you want to call it that. And I then have placed specifically each of those months, June, July, August, and September, across these keys, and I've partitioned a couple of million rows across these drives. So If you want to do this, you can. I would possibly consider using something more like the other script that I have, which is this same scenario just on drive C. Okay? But the one that I've got, the one that I've implemented, and it took about 6 minutes to run, just as a heads up, across these USB keys. Again, not the most performant, but I created a database called Credit PT, Credit Partition Tables, USB, and I took a backup of my old credit database, and I started with that as kind of a framework, and then I changed my database compatibility mode to 9.0. I did not need to take advantage of these features, but I did. I did set it. I didn't need to for these features. I changed the recovery model to simple solely so that I could quickly load the data. Here's where I added a file group. I called it Partition Tables File Group 1. I added a file to it, which is on drive E, as you can see. And just to kind of prove I have nothing up my sleeves, there is Tripp USB 1, Tripp USB 2, Tripp USB 3. Each one of these is a 128 meg USB key, so they're not huge or anything. But literally, I've taken each one of those, and I go through this process to add the files in file group strategically across these 4 drives. Okay, so there's the second one, there's the third one, there's the fourth one, and just for time, I've already executed this. Okay, so then here's the partition function. What I'm going to do, again, the function has nothing to do with the physical location yet, but here I say that I want to create boundaries for June, July, August, and September. Okay, and again, without going every little syntax concept here, but these are just the boundaries. Then I map those boundaries to Partition Tables File Group 1, Partition Tables File Group 2, Partition Tables File Group 3, and Partition Tables File Group 4. Now, it is kind of interesting if I have 4 boundaries, why I have 5 partitions. Okay? The way that partition tables work is they cover the entire set of data from negative infinity to positive infinity. So when you define your partition function, you're going to state essentially where your boundaries are going to kick in. And I did what's called a right-based partition function. So what that means, if I say that I want this value to be a right-based partition function, then that means that that value goes in the furthest, it's the lowest value of the second partition. So right is the lowest value in the second partition. I almost need to do this to show you this. But if you're looking at the partitioning, right, and you say you want to do a right-based partition, you take each boundary, and if you say left, it's an upper boundary of the very first, and if you say right, it's a lower boundary of the second. So the idea here is that my first partition is probably going to be empty. And in right-based partition, that's very likely. You're probably not going to use that lowest boundary because you're not going to have data below, in this case, June. So my second partition is June. Then I've got July, August, and September. So that first is really going to stay empty. I should have gotten rid of that. So I've got a scheme. Then let's go over here. I'm going to create a table, create that table on my scheme. Now here's how everything comes together. I'm saying that the charge date of this table is what should be applied against this scheme. The scheme then maps all of that data to these particular file groups. So then I create some indexes. Indexes by default are partitioned by the same scheme. I don't have to say the scheme, although you can. And you can create indexes that are partitioned by different schemes. There are some reasons you may want to do that, but this is the more optimal case in many cases. So I create the index, and if we want to quickly check with an SP help the table, we can end up seeing the table, all of our columns, and really the one thing that might be interesting is the data is located on file group really shows that it's multiple file groups because it's not on a file group, it's on a scheme which represents multiple file groups. There are actually a series of system tables that you can use to see a lot more detail about what the mappings are. There's a sys.partitions. I'm going to show you some of these in my snapshot one in a moment. Then I load the data. I take all of the different months, load them in, and at the very end, this is what we're going to do now, verify the data distribution. I've got a function where I can pass in the date and find out what the partition number is. This is a great, quick, easy way of seeing what your minimum values, maximum values, and number of rows in each one of those partitions. And remember how I said that our first one really starts at our second partition because it's a lower boundary of the right or second partition for us. So our second partition is essentially June, our third one is July, our fourth one is August, and our last one is September, and I have a little over 1 million rows in there, okay? So now I am, just so that we get ready for some of the disasters that are going to occur to my USB keys, I'm going to change the database recovery model to full, because full is going to give you the most features that I can use in recovery. I'm going to do a backup of the database, and I'm just going to verify that that backup ran. Now, it's going to take a few seconds to do a backup across 4 USB keys. You know, I wish you guys could see the lights just feverishly flickering away here, but it's basically going through, doing my backup now, and we're going to end up damaging this database in a moment. So I would highly recommend doing some testing with this. This is actually a great way to do some testing, although it's not really the most ideal or performant scenario to use. But partitioning your database, you can do this across physical drives. You could do this across these drives like this. So the benefits of partitioning are that you now have the ability to manage each one of these sets of data. Right? I can manage June differently than July, differently from August, differently than September. I could even back them up with different frequencies. I could back up June's at the beginning of July and never back it up again, really. In SQL 2005, you can set a file group to read-only, back it up, and if it ever becomes damaged, you can restore it as long as it matches what the current point in time would be, which if it's read-only, it would match the current point in time. It hasn't changed. So you have a lot of benefits in terms of piecemeal backup. You have lots of benefits in terms of speed. Right? You can now manage your indexes more granularly. And if a file group becomes unavailable, the rest of the data can still be accessed. So let's damage it. In fact, we have to check real quick to see how we're doing on our backup. So the backup's still running. We'll give that, it takes about 3 minutes, I think, total. So we'll give that a few more, hey, wow, it's faster today. 1.5 minutes. So you see that I did a backup, although I didn't really put any good descriptors in there. But I basically did a backup of credit PT USB on, whatever time we are. So great. That's actually perfect timing. So now what I'm going to do, and this script is included, I'm going to go to this database, credit PT USB, and I'm just going to quickly access some data. So now I've just got 4 queries. I'm getting August data here, charge date greater than 0601 of this is 2004 data, so August, September, June, July, August, and September. So we'll go and access the data, and sure enough, I get all of that data back. I've got 4 windows. I only grabbed 100 rows, but I've got the 4 grids. I can grab some specific data here, like September. I don't know if you're interested, but we'll go ahead. We can run that. So there's some specific data for September. But now, what we're going to do is damage August. That's pretty damaged. Okay? So August is now over here. I doubt they can access that. So I'm going to run my query, and sure enough, I have no errors, no nothing. I always kind of wondered, how do they do that? And there's really not much to wonder about, right? Why aren't they failing? SQL Server always goes to memory, right? If that data is in memory, they don't go to disk. Well, they couldn't, right? But they don't go to disk if that data is in memory, so they always go to memory first. I don't see any error. So let's modify some data. I'm going to set charge number 611015, and let's just look over here really quickly in the third grid to see what that data is right now. 611015, the provider number is 427, and the data is kind of garbage data in here, but it's provider 427. So I'm going to go and I'm going to update data, and then I get an error. Maybe not, right? Are we confused? I have seen this before, don't worry. Okay. What about a checkpoint? Now we have a problem. They're trying to flush this information to disk, and that disk is not there. We are now physically trying to write. We can't write to that disk if it's not available. So it gives us this error. let's take a second to look at this error. The operating system has reported an I/O error. The volume has been externally altered, pretty much, right? So the opened file is no longer available. That's pretty accurate as well. To the SQL Server process, add a write, and maybe we don't care about that, but add a specific file. So it tells us exactly what file has our damage. Okay? Additional messages in the error log. Right? This is a severe system-level error condition that threatens database integrity and must be corrected immediately. Complete a full database consistency check. This error can be caused by many factors. For more information, tell me that is not one of the best error messages you've ever seen. I actually sent a thank you email after I got this. I'm like, I can't believe this. This actually didn't say contact your system administrator. Right? You know, I always get those messages, and I'm like, that's me. Now what do I do? And this is a consistent thing you'll see across SQL Server. They have made a really solid strategy of changing error messages to make sense and be more useful. So I really like that. I actually put that into your script. Now, here's what's kind of weird, right? The query still works. The data's still in cache. I tried to do a write. I got a write error, but the database and the data that's in cache is still technically available even for writes, because writing to the log isn't damaged. So everything about this database really is still staying available even though it's clearly not fully available. So the question is, how do we proceed from here? Well, you would be getting errors. You would know that you're getting errors in one of a couple of different ways. Now, first of all, I would strongly suggest that all of you take some time to make sure that all of your errors that are written to the error log based on any severity greater than 19 automatically send you a message. It's a very easy thing to do with the SQL Server agent. You can basically say, any error of any severity, send me an email. So learn a little bit about the SQL agent if you're not already using that, because you can just generically lump each of the severities into send me an email. So the sooner you find out you have a problem, the easier it is to fix it. But this also gets logged. Well, let's look, actually. Here, using the credit PT USB, if I look at the system table, sys.filegroups and sys.database files, what we're going to look for is something called state. And you're going to see that all these files are still technically online. This error is kind of a soft error in the sense that it could have been a cable that's pulled. It could be a drive that ends up being replaced and is accurate. But what they also do is they log a message into a table called suspect pages inside of MSDB. And this is another way that you can monitor, is go to suspect pages. And you'll see database ID 12. So if we don't know what database ID 12 is, I can run just a query here. I've basically got database name of database ID right here. So if I put in my database ID, okay, 12, and just run that really quickly, you can see it's credit PT USB, which is exactly what we thought. Okay, put that back in. And in there, suspect pages, we can end up seeing that there is an event that occurred, right? Event 1. Well, that maybe doesn't tell us much. So this query that I wrote basically converts this into a little bit more usable information, right? Credit PT USB file 3, right? The error type is basically it's labeled as a short transfer, which means that they had problems doing the write to the disk, but it's kind of a soft error. So, okay. There is a section in the books online. I have links to each of these. There's a section on suspect tables and a section on the suspect pages table. And I don't know if you've seen this yet, but you can even click on hyperlinks inside of scripts and launch things like the books online inside of Management Studio. So these will directly allow you to connect and link to this. Okay, so going back to this, you might want to take some more time and investigate further your different files and whether or not they are damaged. But what you're very likely to want to do at this point is take that particular file fully offline. You want to take it offline because that disk is damaged, so now you're going to end up replacing that disk and wanting to replace that file from a backup. And then you're going to have to roll it forward with transaction logs. So I'm going to take that particular file offline, and there are essentially two things that occur, right? They have to basically check the database state very quickly, so they disconnect users to make sure they've got a consistent state of the database, and then they immediately allow everybody back in, and they then have a second error because they couldn't really physically touch the file. It's the same error that we saw before. But at this point, the database is back online. It is available. It was only taken offline for a brief second to make sure that we had a consistent state from which we could guarantee the log, right? So quickly taken offline, and then it's back online again. I can check the database file state at this point, and you'll see that everything else is still online. The only one that's offline is that third file. I can access data as long as it's online. Even in this single table that is partitioned, all of the partitions that are still available are still accessible. Okay. And now what I'm going to do is try to recover. But think about the timeline of what's happened. I did a backup after I set everything up. Okay. I then had some changes. Then I damaged the file. And then I may have had more changes. Then I took it offline. The point at which you take it offline is what we call the sync LSN, the sync log sequence number. So what we have to do always is after we take it offline, get what we call the tail of the log, the changes that have occurred since the last backup that we performed. And with that log, we'll be able to reconcile this database. So the way we get the tail of the log is to back up the log with no truncate. Okay, so I back up the log with no truncate. This is going to get the tail of the log, all of the changes since the last log backup. And then, to recover the database, I'm going to restore just the file. This is kind of an important point. I'm not going to restore the whole database, even though I'm using a whole database backup. I'm going to restore just this file from the backup. So I'm going to restore just this file. Then, once I restore the file, I'll have the file at an earlier state, and the rest of the database is way over here. So to get this file up to and in line with current, I have to then roll forward with the log. The log will know what is needing to be applied. So there's nothing special that I have to do in my restore log. I restore my database, I restore the log. We give it a few seconds here, and once it is restored, okay, it's just doing the file. I do have to admit, restoring a file from a full database backup takes longer than restoring a file from a file-based backup. Because if you're restoring a file from a full database backup, they have to find that file in that full backup. So the bigger the database, the more likely it is that you may want to strategize for this by doing file-based backups. But there we go. There was our restore database. There's our restore log. And now, if all is good, we can go and access June, July, August, and September and end up back fully online and available, every file group, and the database stayed available really through the whole process in terms of all of the other data. June, July, that is cool, isn't it? Thanks, you guys. I'm really pleased with this particular feature, especially because I get to do fun demos. So, all right. So the damaged partition does not render the entire database to be unavailable. Only that damaged portion is available. Even if you use the old partition views scenario, the entire database remains online with the exception of that which is damaged. So you don't have to use partition tables. You can use partition views. Okay, so both of those features. For those of you that have partition views, you can literally upgrade and immediately start taking advantage of this feature with no changes. So that's a nice capability. Okay, users can access the database during the restore, and you really only have a minimal impact to your database at the time you take the file offline to basically sync up the LSNs, and at the time you do that restore. And it's, again, just for a second to sync up LSNs. So outside of that, the database remains available. Okay, and I've already done that one. So recovering from hardware failure, that's kind of the easy case, really. To be honest, I like hardware failure way more than any other types of failures because it's clear what's damaged, right? You can go to the error log, and the error log would show you that you have an error to a particular file. Those 824s, that I/O error, that is basically an 824 error. It's a Sev24 as well. So severity 24, it's an 824, 823, and 824 are your disk errors. So you can actually go to your error logs and look for these specifically, and they'll tell you which files are damaged. And of course, you can very easily have your agent send you information about the damage when certain errors occur. So really, really easy to know about hardware failure. And take that one step further. if the hardware's not there, right, then it's not likely to cause a lot of secondary damage. But when you have human error, there can be a huge amount of secondary error from that because people continue to further use that potentially damaged data, and then how do you even know that it's damaged? Right? Depending on what the cause of that damage was, it could be extremely difficult to end up figuring out how to recover from there. So, let's talk about some of the things that you should put in place preventatively. I would strongly suggest preventative techniques over anything else, because if you can prevent the disaster altogether, then you don't have to worry about the complex, painful, possibly error-prone and time-consuming recovery process that will have to ensue. So, this is a new feature. I've talked about this in a couple of sessions. I want to spend a lot of time here, but DDL triggers. This is one of the features that I've had people that look at my script and say, I am going to put that script into production the first day my database goes online in production. It's a very simple thing to do, but you can trap DDL. And you can trap DDL at a variety of different levels. I'll give you a little bit of insight into that in a second. Event notifications. This is an asynchronous way of trapping events, and it can trap way more events than just DDL. So you can end up seeing if certain events occur, and then you can respond to those events with something called an event notification. So you should read up on those. Those use Service Broker, and they can do amazing things in terms of like a mirroring state change. You can end up taking a database offline, or you can do all sorts of things that you want on almost any different type of trace event even, not just DDL. I generally recommend no direct modifications to base tables. This is more of a developer feature, right? You have to look at the way you design your tables and the way that they're accessing those tables, but I never try to allow users direct access to the base tables. Stored procedures, views are going to help you with that. And then agent alerts, it's not necessarily a preventative technique as much as it is a technique that will tell you that you have a disaster coming, especially if you've only had a few errors at this point. So just this DDL trigger really quickly. What I've done is and you know what? You don't want to just stop the DDL, do you? Right? Somebody tries to do a drop table and you don't allow it. Well, that's great. But don't you want to know that somebody tried to do a drop table at some point? So what I've done here is I've actually done a combination of things. I'm going to create a table called Audit DDL Operations. Now this is kind of a reactive strategy, but it is a measure that's very helpful if some of the other safety features don't take effect. So I'm going to create an audit table inside of AdventureWorks, and then here is, and that's all of it right there. I'm going to create a trigger called Prevent All DDL on the database. It's going to be encrypted so that nobody can see that. Then, for DDL database level events, this is a group. What you have in 2005 are events, DDL events like create table. And you could say for create underscore table. Basically, whatever the DDL is, it's likely to be the same thing with an underscore. So you could say for create table, you want an error. So you can do this at each individual event level. Then there's event groups. So there's a DDL procedure events group, which is create procedure, alter procedure, drop procedure. And you can end up having a different scenario occur just for that. Or you could do this, and you could say, I want all DDL that occurs to be trapped. So now I'm saying create this trigger on the database for DDL, database level events. And what's going to happen is there's a new function you can call called event data. It's going to trap in XML form all of the event information that occurred to cause this trigger to fire. Then I'm going to raise an error that says you can't do this in production. No DDL is allowed. And then I'm going to insert the information into the audit DDL operations table. The order in which I wrote this is very important. If you roll back at the wrong time, you may roll back your insert into your audit table. Definitely do some testing. Okay? So, believe me, I've seen that. So I create this trigger, and I now try to create a table. I try to drop a table. Doesn't matter. DDL operations are prohibited in this production database. Please contact IT operations for the proper policies and change control procedures. And of course, both of these generated the same message, and both of them ended with killing the transaction. So if I go over here to my audit table, we can see that the operations occurred, when they occurred, what the type of the event was, and the actual full syntax of the event which occurred, I think there's a cutoff of something like 2,000 characters, but pretty good. So I'll clean this up. Oh, and kind of funny, drop trigger does work. They fixed that. There was a version at one point where you couldn't drop the DDL trigger to drop any of your objects, so you got stuck. That has been fixed. So now, recovery techniques. If we talk preventatively, that's important, because then hopefully you won't have to recover at all. But we're not going to be able to prevent everything, okay? There will be some point in time where you're probably going to have to recover from some type of human error, some type of disaster. Now, if you recover the entire database to an earlier point in time, there is a strong pro to that, in that you are guaranteed data integrity to the point in time that you have recovered to, okay? So that is a very, very, very big pro. But the con to that is if the error occurred 6 hours ago and you have to roll the whole database back to 6 hours ago, that means you've lost a lot of other changes which may not be desirable. So what a lot of us do is we restore, like I said, to an alternate location, figure out when the data went bad, and then we take a version of the table when we manually merge it in. Okay? Very, very common. The pro to that is that all those other secondary changes can still exist within the database. We're reinventing history to a certain extent, and that may mean that some of those other modifications are bad, so we really need to know our data well to do this, but this is by far the most common strategy that I see used when there is partially damaged data due to human error. But it is very time-consuming, mostly because of the restore. We have to restore to an alternate location, and that takes a tremendous amount of time. So if we really want to see data from an earlier point in time, we have a new feature to help us do that. And that feature will allow that database to be available and online, right, immediately. Because we're going to proactively strategize for this as well with something called a database snapshot. So what we're going to do is take a database and, let's say, periodically, maybe every hour, maybe every 4 hours, we're going to create a snapshot of it. But before you go, oh my God, I'm going to create a whole snapshot of the entire database, isn't that going to take a tremendous amount of space? The answer is actually no. This feature relies on an underlying feature of Windows to create a snapshot of the database using what are called NTFS sparse files. So I'm going to give you some concepts on how this works and then show you this as well. So I would strongly suggest, once you know exactly how this works, to create your snapshots in some form of a rolling fashion. This is a proactive, you have to do this proactively. Okay? But you might say at noon I'm going to create a snapshot, and then at 1 p.m. I'll create a snapshot, and at 2 p.m. I'm going to create a snapshot and get rid of the noon. And at 3 p.m. I'm going to create that and get rid of 1. And I'm going to keep moving forward from there. So the way that you create a snapshot is you use the create database command, and you specify a location for every single one of the data files, but you don't state the size. You just state the location. And then you state in that definition that this is going to be a snapshot of whatever database it is that you want to create a snapshot of. So creating a database, whatever database name on, and then you list all of the data files and their location. That's it. So every data file and its location, then you say as a snapshot of, and I've got a script for this, I'm going to show you this. And when you want to drop a snapshot, you say drop database. I remember the first time I saw that, I'm like, oh my God, can you imagine the accidental error that could occur with this one, right? Drop database credits, and you meant to drop the snapshot, right? Good news. If a database has a snapshot, you can't drop it. Phew. Right? So then I kind of went, okay, so drop database is okay. But I almost wanted a new command, like drop snapshot. But drop database, snapshot name will work. Drop database, database name won't work if there are snapshots. So the snapshot kind of protects you from doing that, which is good. Now, the way that you create this, you have to have every single file specified. So what I did to make your life a little bit easier is my snapshot demos are based on that same credit PT, credit partition table scenario, but with it solely on drive C. So if you want to see partitioning, this goes and creates everything, partition tables, file group 1, file group 2, file group 3, all the way through, right? and does the same partition function, the same partitioning, and if I say use credit PT, okay, you can see that I have all of that same data partitioned as well in that database. Okay, so I have this on drive C as well, mostly so that you can see both of these scenarios and throw the snapshots in, and you don't need to have anything like this. So the snapshot, okay, the way that you create it, so I'm going to use credit PT, and let's just quickly see our files, just to remind you, right? We've got 4 files and a staging file. If I want to create a snapshot, again, just to remind you, we have to state every single data file. So every single data file, and I chose one that was a little bit more interesting than a 2-file database as well. So this is a database that has really 6 data files. So I state the location for each one of these data files. Okay? Oh, I already have one. Well, we already know what that syntax is, don't we? Don't you love highlighting? Love and hate, depending on how you highlight. But I'm going to create a snapshot right now at this point in time. Okay. And there is a series of system tables that you can access. This is a little bit ugly of a query, I have to admit, but I've already written it, so you can just steal it, leverage it, whatever the right word is. But I can run a query very quickly against a couple of system tables and a DMV to get a whole bunch of details about this snapshot database. So there's my snapshot. These are the files, right? And these are the file names logically in that snapshot as well. These are sparse files. Okay. Then, here is the thing that's interesting. What I did is I grabbed from the system tables both the logically defined file size as well as the physical size on disk. So what you end up seeing is that these files have been defined as 500 meg, 100 meg, 100 meg, 100 meg. But did you see how fast that snapshot got created? There was no way that it created a database that was basically a gig in just a second, because it didn't. It created what are called NTFS sparse files. So let's talk a little bit more about that for a second. Okay? What you have in terms of an NTFS sparse file-based database snapshot is not the database being copied, because that would take a while to copy, especially in a VLDB. But if you create a database, they will literally create the framework of that database as skeleton-like files, files that really don't have any data in it. Once the data changes, you have a copy on write mechanism that literally says, oh, use credit, update, and a couple of extents get updated. Those extents end up being copied to the snapshot. But only those extents. Then somebody wants to do some type of select, and what will happen when you select through the snapshot is they will look to see if the extent is in the snapshot, and if not, they'll go through it to the base database. What this means is that the base database's files have to be available. This only works when the database is not damaged. This only works as a read-only copy in the cases where the database is still available and not damaged. It does not work when there is physical damage to the database files. Okay? But now we have an image that's extremely inexpensive that we can query against in terms of disk space. Right? It's extremely inexpensive in terms of disk space, and we can query against it to have what the data looked like at a certain point in time. So, you need to have create database permission. You need to create this on NTFS partitions and NTFS drives, and it has to be on Windows XP or Windows 2003 server or higher. So you can't do this on earlier versions, right? The resulting snapshot is completely and totally read-only because it's relying on the base information to actually give the information back to you. There are absolutely no changes allowed in the snapshots. You can't change permissions, you can't add indexes. It is literally just a point-in-time image of exactly how that database looked at that point in time. Okay? You should come up with some form of naming convention if you're going to create rolling snapshots as well. Now, they have to be on the same instance. These can't be on different servers, right? So really important to realize that this is on the same server. You can't do, and I'm hoping in the next release, or even maybe a service pack at some point, if there's maybe a .a or something, I'm hoping that you will be able to do backups of snapshots, but you can do a backup of the base database. You just can't do a backup of the snapshot, so that's a limitation. But they are space efficient, right? They don't require a complete copy of the data. They use an underlying mechanism. This isn't really even SQL technology that's doing this. The database may impact performance, though, okay? Luckily, it's only on the first write, though. Remember that. Some people think, oh my God, once I have a snapshot, then every write incurs overhead. No, it's only every write the first time it writes at the page level. So when that page is written, it gets copied. If that page keeps changing, they only write it that one time. So this is not a big negative at all, unless every page of your database is extremely volatile. But when you have data where some of it is extremely volatile and some of it isn't, this is extremely space efficient and not going to negatively impact performance. Now, in Windows, you can actually check the file space there. You're going to see the file size to be the same size as, I'll go over here to data. I just created these. I usually name them the same name as the file, but I end up adding snapshot at the end. So these are my snapshot files. See how they say 100 meg here? They're really not 100 meg. And the only way you can see that is by going to look at the size on disk. Okay, so you can see the physical size on disk, or you can run those system table queries that I was showing you a moment ago. But this is an easy way to see the size on disk. Okay? And this is that query. It is in there. This is actually slightly changed. I added even more detail to it in the script, but this one works really well as well. Okay? Now, a little bit more that I want to show you on this, and then I'll round out the rest of this. Okay? If I go, and I'm going to actually change the date. I'm going to choose a different date. I'm going to do the 10th of August, and I'm going to change that to be the 10th of August. So it's a little bit weird what I'm going to do. I'm going to change a charge amount to be the 10th of August for the 10th of August. I know that's a little bit weird, but I'm just doing that inside the credit PT database, the actual source database, to end up seeing what the snapshot ends up happening with. And before I go too far, let's look at the size of August again. If we look at the size of August on disk, the size of August, which is the third file, is currently 64K on disk. If I go and modify August's data, I still have 3 minutes. If I go and modify August's data, then what's going to happen is I am going to write that information into the snapshot. And what we'll do really quickly here is change this to August 10th. I was doing an earlier date, so I want to change this just to be our date, which is easy. So we're changing this between these two databases, and so what I will do is check the data in the snapshot version of the database versus the current version of the database, and you can end up seeing that the snapshot value has the prior value, and the current value is this weird value that I set to essentially today's date, or August's date. So now, what happened in terms of the file size? Let's just do this query before we do the other transaction. Now, we'll see that the sparse file has been populated with the data that's changed. So this is all that gets written. Okay, this is all that gets written. Okay. Now, this is an important point to make. If I begin a transaction, technically the data hasn't committed, but it is a copy on write mechanism that occurs. This is August 7th. Let me do the 11th. August 7th doesn't need to change. Roll back my tran. And there we go. Let's do a different date, because that came back awfully quickly, didn't it? So I'm going to do August 11th now. Now, what's happened? It increased, even though the transaction hasn't committed. The reason why is it has no idea of the state of the transaction. It is literally just when the pages are going to change, we grab them, we write them in a copy before write type of mechanism, regardless of the state of the transaction. That's just a point that I wanted to make. It's not a big deal. Even if the data gets rolled back, that information stays in that snapshot. Now, I would expect you don't have a lot of transactions ending up rolling back, but it is a good point to make that you incur the overhead anytime the pages are written, regardless of the state of the transaction. Now, I can go and check the data. I'm not worried about doing that. I can begin another transaction and in another window create another snapshot. This is something you can play with. I wanted to make this point. A snapshot is always the point in time when you create the snapshot. So if there's a transaction in flight, what ends up happening is they create the snapshot, and then SQL Server uses the transaction log to roll back the data to the point in time when the snapshot occurred. So that may take a couple of extra seconds for the snapshot to create and exist. Now, at the very end of this script, how do you revert back? What if you want to do this? You want an image. Think about this for testing. You have an image of the database. You want to do a bunch of stuff and revert back. You can create a snapshot very easily and revert back. So the way I revert back, restore database from my snapshot. Now, this is going to work for me, but if you have multiple snapshots, you have to drop the other snapshots before you can revert back. But I don't have snapshot 2. I didn't create that. So if I revert back, I can get back to the image of the database as it looked when I started this whole process. So you can start, create a snapshot, make some changes, revert back. Okay? So I'll give that a few seconds. I might have some other windows in Credit PT, and that's probably giving me some grief here. So it's probably going to tell me could not get exclusive. Ah, there we go. There we go. So I've now reverted back to the original image of the database. So how do you use this? I have basically 2 minutes to wrap up here. But how do you use this? You've got an online version of the data that you can connect to, that you can look at, you can analyze, and you can see if you have problems, and you can see when the data was accurate, and then you can end up querying that data or even just doing like an insert select to bring the data immediately back over to production. So in terms of having something available that's lightweight and not very costly, you've got that capability here with database snapshots. So you can revert the entire database, or you can end up doing something like this. Insert into your damaged database whatever your object is, select from your database snapshots data, and insert that data over. Or like I said, you can revert the entire database back to an earlier point in time. So this is a great feature to look at, analyze, and even recover from that's online and available and doesn't have a costly restore associated with it. But it is a point in time image. So you want to create multiple of these over the course of a day and so forth so that you have multiple choices to recover from. So point in time from your snapshot and manually merge in is great because it's fast, it's easy, it's there, it's available. Restoring your backups to an alternate location does mean you can inch further forward with logs. So that might get you closer to the point in time of the damage, but it does take a lot more time and a lot more work. So you have a couple of options. I did write a 7-article series that starts with the instant doc that's at the bottom on how to inch forward within databases to actually see what the errors are. So I put that article number there. So you do have some other resources. In fact, speaking of resources, there is a snapshot isolation white paper, there's a partition tables white paper, there's a strategies white paper, and a 2000 partition tables white paper. I have a bunch of stuff on SQL skills, and I will be posting all of the demos there, as well as the conference DVD, so you might find that really useful. There's lots of community resources out there, learning resources, and make sure you fill out your evaluation, and I will see you guys again. Thanks a lot.